Hello, here we'll be looking at now angle of elevation and depression, which is also an application of the trigonometry of right angles triangle. So what is angle of elevation? An angle of elevation simply means here, as you can see in this diagram, it simply means you look up, right? Looking up. Depression stands for looking down. So now, how do we get an angle of elevation? So if you look at this now, this is a horizontal line. So this is we call it line of sight. Now, let's say you assume you have something above that you want to look. Sometimes you have to lift your head to sight something. Now, your horizontal line, let's consider it as our initial sight. So if you are looking up, you're going to have an angle here. This is your terminal side. Let's say you have, let's assume you want to look at the roof, right, of a house. Or let's say you have a bulb there. Let's say you have a bulb in a room, right? And you have to look at it. You raise your head. So now there is an angle formed between your eye of sight, your line of sight, and what? And this line is now your terminal side. This becomes your terminal because this is where your eye terminate. I mean, when you lift up your head, right? So you see now this angle theta is what we call the angle of elevation because it is formed between your line of sight, which is now your initial sight, and your terminal sight by looking up, right? But in this down, now, if you look down, instead of looking up, we look down. So we'll have another angle here. Let's call this angle alpha. So you have another angle formed here. So this angle, let's call it alpha. So this alpha is going to be our angle of depression. So remember, an angle is formed between what? Initial side and terminal side. So take note of that. So let's see a few examples here. Example 6 now. What is important is always our point of reference. It says from a point on the what? From a point 10 feet from the base of a flagpole. So now the first thing is you need to identify this is let's say this is our flagpole. And let's say this is our flagpole. So from a point 10 feet, let's say this is the point. It means the distance between the base, 10 feet from the base of the flagpole. This is the base of the flagpole. So this is 10 feet. The angle of elevation. So this horizontal line will be our line of sight now. So the angle of elevation, it means you have to look up. Elevation to where? To the top of the flagpole. Where is the top of the flagpole? This is the top of the flagpole. So it means you have to raise your head and check the top of the flagpole. And this is the angle of elevation, which is just 45 degrees. And now you want to find the height of the flagpole, which is just going to be this distance here. Let's call it X. And here definitely there's going to be a right angle because you have a vertical pole and you have a horizontal line, which is the base. So you have these two lines will be perpendicular. So you have a right angle. Now to look for S is clearly, this is our hypotenuse because you have our right angle here. This X is our opposite and this 10 becomes our adjacent. So the best thing to use is going to be tan 45, which is just going to be opposite X over adjacent, which is 10, right? But what is tan 45 is 1, so you have this. So it means that X is going to be 10 feet as well. So the height of the what? The height of the flagpole is just what? 10 feet as well. All right. So example 8 is saying that what? If you have an airplane, which is flying 300 feet above the ground level, an airplane is flying 300 feet above the ground level. So where is the ground level? This is the ground level. Now, 300 feet above the ground level, it means the distance between the ground level and the height. So let's say this is the plane here. Okay. So the plane is going, the distance between the plane and the ground level is 300 feet. Yes. So so this will be the line of sight because the plane is going horizontally, right? But here we have a full stop. If the angle of depression from where? So here we're interested in depression. So it means you have to look down, right? The angle of depression from where? From the plane to the base of a what? Base of a tree is 30 degrees. So it means this is the tree. So let's assume that this is the tree. This is the roots. So here, it means you're going to have an angle of depression to the base of the tree. You'll be looking down to the base of the tree. So here you can see the angle of depression is this one. This is our theta because it is formed between the line of sight and the terminal side. So it is not this one. Alpha is not the angle of depression, right? So take note of that. So our angle of depression is 30 degree. So this position is our 30 degree, not this one. Because if you put it here, you see it. This is an angle formed between this vertical line. And this is not our initial side. So, and this terminal. So an angle of depression must be formed between the initial side and the terminal side. And what is the initial side? Is this line of sight. Okay. So now what are we interested in? We said find the horizontal distance the plane must fly to be directly above the tree. So the plane is flying. So at this point, the plane is directly above, right? So we can have our line here. Yes. So it means we're actually interested in the distance traveled by the plane until it comes on directly, must fly directly above the plane, above the tree. So this is the distance we're looking for. We call it X. All right. So how do we solve this? We can use the fact that if this distance is 300 feet, then this distance also has to be 300 feet. So, right? And then we can find it easily. We can find X easily. So here you can see, one way this is one way we can solve it. So let's finish it this way. I'll tell you the other one. So this now going to be opposites over what's here. There's going to be a right angle here. So it means this X you are looking for, it's our adjacent. So we have that tan 30 is simply what 300 feet over what 300 feet over X, right? But what is tan 30? Tan 30 is what? Tan 30 is simply root of 3. So here you have root of 3 is equals to 300 over X. Tan 30 is not root of 3, but 1 over what? 1 over root of 3, which is the same thing as. So it means that X is simply 300 root of what? Root of 3 feet. This is one way to solve it. Now, another way is this is the first method. Let's say method 1. Now, if you want to use method 2, what you can do, let me use a black pen here. what we can do is, since we know that here is what is 30 degrees, so here will become what? Will become 60, right? And then we can find the distance. The distance from here to here also is going to be the same. If this is x, this is also going to be x, right? So it means we can use, and here is also going to be another right angle, right? So we can use what? We can use opposite over, this is going to be opposites, yes. Opposite over what? Still adjacent, all right. So here we can say tan 60 is now not tan 60, not tan 30. So tan 60 is still x over what? Over 300. And what is this? This is root 3 is x over 300. So you can see that x is still 300 root 3. So any method we use is still fine. All right, now let's look at example 8. For example 8, it says the angle of depression from the what? The top of a building to a point on the ground. So angle of depression from the top of a what? Of a building. So we have to consider the building. Let's assume that this is the building. If this is the building, so this is going to be the height. This is the height of the building. So this will be our line of sight. Then the angle of depression from the top of a building. Okay, the angle of depression from the top of a building to a point on the ground. So it means you have to locate a point on the ground. So let's assume this is the point on the ground. So the angle of depression, so it's going to be this angle, is what? Is 30 degrees. Yeah. So when we want to find what? We want to find how far here, because we are looking for how far is the point from the bottom of the building. So this is what we are looking for, this distance, right? So just like we did earlier, we can still solve this in two ways, but let's just solve it in one way. If this is 30, then automatically this becomes what? This becomes 60 degrees, right? So once we have the 60 degree, we can easily find what we want, what we are looking for, right? So let's take away this one first. So okay, now this is 60 degrees. So if we have 60 degrees, then we can find this x, but we don't know the building. The height of the building is known, so 252 meters, right? Yeah. So to find x, we can just use sine. So sine 60 is going to be, is it sine 60 or tan? Tan 60, because there's a right angle here. So tan 60 is going to be x over what? 252. And tan 60 is root 3, and this is 252. So x is what? 252 root of 3. All right. Now, example 9. Example 9 is about a ladder of 6 meters length, which is placed against a wall to form an angle of 45 with the horizontal ground. So what we have is that you have a ladder here, right? So let's say you have a wall here, and you have a ladder of length 6 meters, which is placed against a wall. So here you can see the ladder is what? Is 6 meters. It's placed against a wall at an angle of what? 45 degrees. So this is 45 degree with the ground. So it makes an angle of 45 degree with the ground. Okay. So this is what we have. This is the wall. We are not given the length. We don't know the height of the wall, right? So this is the first statement. A ladder of 6 meters placed against a wall forms an angle of 45 with the ground. Now, if the foot of the ladder is moved closer to the wall, so it means this is the foot of the ladder. You move it closer to the wall. So you bring the foot somewhere here, right? If you bring the foot somewhere here, this is the top of the ladder. Definitely it's going to move upward as well. So it's going to move somewhere here. But now with which angle? With the angle of 60 degree, right? Okay. So that's it. Now, what are we interested in? The angle changed to 60 degree. Find the exact distance moved by the top of the ladder on the wall. So this is what we are looking for. We're looking for this distance here. Because by the time we shift this closer to the base, to the wall, the height here will shift. The top of the ladder will shift also up. So this is what we are looking for. Let's call it what? H1 or H2. So let's call it H2. Okay, we are looking for this distance here. We can call it anything, we can call it X. Let's call it X. Right. But here, the distance, then this place, let's call this one Y. Right. So what we can see is that we can try to get Y first, right? Or we can try, we can try to get Y first. What do we mean? Let's do some labeling here. Let's call this A. Let's call this B. Let's call this C. Then this point, let's call it D. So let's consider triangle. Let's start with what's DCB. DCB. If you look at DCB, you will see that we can get what? To get Y, we can use opposite over what's hypotenuse. So you can see that sine 45, if you look carefully, is going to be what? Is going to be the line DB over what? Over DC. Yes. I'm using triangle DCB. So take note of that. Okay, but what is sine 45? It's 1 over root of 2. What is dB? dB is just y, so this is y over DC is the length. That is the length of the ladder, which remains 6, right? So you can see that here you will have root 2y is equals to 6. So it means that y is 6 over root of 2, which we can rationalize so that this will become 3 root 2. So this is y. Then let's consider the big one. Let's consider the big triangle, the one with 60 now. So this will be triangle. I think here also we need to label something. Let's call this one E. All right. So let's look at triangle A, E, and B. So in triangle A, E, and B, we can use the 60 degree at E. Let's use this 60 degree at E. So opposites over hypotenuse, I think. We can still use sine 60. So sine 60 degree is going to be the whole of opposite now. Our opposite will be the length AB. Yes, that will be all the opposites, A to B. Then the hypotenuse is going to be AE. But what is this length of AE? It's still the length of the ladder, which is still 6 meters. It doesn't change. So what is sine 60? This is root 3 over 2. It's equals to AB. So you can see AB, we have x plus y. Over AE is the length of the ladder, which is still 6. Right? So here we just need to solve things. So if you cross multiply, you have 6 root of 3 is going to be 2 times what? X plus y. If you divide both sides by 2, you will have 3 root 3. It's equals to what? X plus y. And then remember, what are we interested in? We're interested in x. So x is going to be 2 root 3 minus y. But what is y? Y is what? 3 root 2. Yes, so we have 3 root 3 minus 3 root 2. Am I correct? Yep. So here we can take 3 as a common factor. So we have root 3 minus root 2. And this should be the length it moves. So 6, it's going to be in meters. So this is the distance we are looking for here. All right. So this is 9, all right? So now let's solve the last one here, which is example 10. So for example 10, it says that what? 20 feet ladder also lean against a building. So let's say this is it. All right, 20 feet leans against a building. We don't know the height of the building, but we know the ladder. The length of the ladder is 20 feet. Okay, and a 20 feet against a building, so that the angle between the ground and the ladder. So this angle, this is the ground, the ladder here, and this is the ground, right? So the angle between this is what we call alpha. Yes, so this is alpha here, alpha. And then what we are given is that tan alpha is what? Tan alpha is 1 over 2. So how high does the top of the ladder reach on the what? On the building. So here, we remember this is the building here. The building is this one. Let's call this is the building. So how high the ladder reach on the top of the building. So you are looking for this length here. Let's call it X. Okay. So, but the thing here now is this. We don't know what is alpha, right? But from here, let's see from this diagram, what will be tan alpha? Tan alpha is going to be opposite. So it's just going to be the X over the adjacent. Okay, so we don't even have tan alpha here, but let's use something different here. Based on the information we have, if we want to find X, what we can use is sine alpha, because sine alpha is going to be X over what? Over 20, right? X over 20. But we don't have this, we don't know what is alpha and we don't know what is X. So what we can do, it's simply, we can always form another triangle somewhere else. or we can still use this information, it's fine. So if we are given that tan alpha is 1 over 2, right? So if tan alpha is 1 over 2, so you can just let what? And remember, what is tan? Tan is what? Is opposite over what? Adjacent. So what simply means is that if your opposite is x, yes, then this should be what? Twice of x. We can use this argument, right? So then we can easily find it. So this is x and this is twice of x. Then we can use Pythagoras theorem to find what is x. Is that okay? Because this x is what we need. Don't forget, let me come again. But before I do that, let me just leave this for now. Let's say we don't know what is this, and we want to use this information. I said sin alpha is x over 20. This is clear. Now, look at this information that you are given. You can just come here and create another small triangle, call it alpha, and use this information. This is going to be 1 over what? Over 2, because tan alpha is opposite over what? Over adjacent. Then by Pythagoras theorem, clearly this is going to be root of what? This is going to be root of 5 by Pythagoras theorem, right? So it means you can easily get sine alpha from here. So sine alpha is going to be 1 over what? Root of 5. Yes? Now, what you can do is just come back here. If you come back here, what is sine alpha? Sine alpha, just use 1 over root of 5 equals to x over what? 20. So it means that what? X is going to be 20 divided by root of 5, which we can rationalize with root of 5, root of 5. So x is what? 20 root 5 over 5. And this is what? 4 root of 5. Yes. So this is one way to solve it. What did I do? This is the information. We're looking for the height, how high the ladder goes, which is x. And we have the length of the ladder, which is 20 feet. Now from here, this is alpha, because alpha is the angle formed between the ladder and the ground. So sine alpha is going to be x over 20, right? But now you don't know what is sine alpha. So just use this information that you are given, form another small right angle triangle somewhere. So if tan alpha means what? Opposite over what? Over adjacent. You can use Pythagoras theorem to find root of what? Of 5. So we got this root of 5 using based on what? On Pythagoras theorem, right? Okay. Then you can find sine alpha. Then bring that sine alpha back and you will have this one. Now, that is one method. Another method that you can use, which let's call it second method. The second method is also easy. You have the diagram like this, right? So this is what we have. This is x, and this is 20 feet, right? So remember, you are already given from the question that tan alpha is what? Is 1 over 2. So you're given that tan alpha is 1 over 2. So if this is x, remember, this is what you are looking for. For you to get 1 over 2, it means you have to make this one to be 2x, right? Yes, because tan alpha will be x over what? 2x, which is going to be 1 over 2. This makes sense, right? So with this, we can find x. We can just use Pythagoras theorem, right? So we see that 20x squared, 20 squared is going to be x squared plus what? 2x all squared, right? So this is going to be 400, and is going to be x squared plus what? 4x squared. And then you will have 400 is equals to 5x squared, right? And we can divide If you divide by, you can divide by 5, and then we'll be fine, right? Yes. So this is 400, and this is x squared plus what? 4x squared. So 400 is equals to 5x squared. If you divide both sides by 5, what are we going to get? So x squared is 400 divided by 5. And this is nothing but 80, right? So x is the square root of what? 80. Definitely we take the plus 1. And this is nothing but 16 times 5. Am I correct? Yes. And this is simply 4 root 5. All right, so that's it. The next video will be on the exercises. And thank you for watching.